geometric proofs. Now, alright guys, now, express 1 over z in this form here. Okie dokie. So what do we have? 1 over 3 into cos pi plus. Just out of interest, did anybody multiply by the conjugate top and bottom? Did anybody else try that? Did it work for you? Yeah. You don't have to use 3 though, do you? You just need to use the conjugate top and bottom. Using the conjugate top and bottom will actually move the everything back to the top again, and then we can figure it out from there. So let's find out. What's the conjugate of this? Anybody? Cos pi minus I sine pi. Is that right? And then cos pi. We cut that. Now, we're going to multiply this out. So it's going to be cos pi minus I sine pi. And then on the bottom, what's going to be on the bottom? How do you multiply this out again? What's cos pi by cos pi?
Cos 2 pi.
What?
Cos 2 pi.
Cos squared pi. And then it's minus I sine pi cos pi. How many of them is there? They're going to cancel each other though, aren't they? It's the difference of 2 squares, so does that mean you need to be even concerned about the middle part? You don't, they're just going to cancel anyway, so I'm not even going to bother. Alright, now what about the last part? What's I sine theta multiplied by I sine theta? Minus I squared sine pi. And what's minus I squared? Sine squared. I squared sine squared pi. So we pay you the big money. Now what next? Yeah, sine squared pi. Now, does anybody know what cos squared pi plus sine squared pi actually is? It is 1. Because cos squared any angle plus sine squared the same angle is always 1. So what does that mean we have left here now? We have 1/3, what is it? Yeah. Alright. Now, do you know what we might just do here? We might just change it back into its regular coordinates. How do I do that? Huh? Now, you're probably wondering why I'm doing that. It wants it as a plus. I clearly have it as a minus, so I'm not happy with that currently. Now, what is cos pi? Cos 180? It's minus 1. So, this is actually minus 1/3 plus 0i. Is everybody cool with that? That is minus 1/3 plus 0i. Now, if I drew the xy diagram here, like so, where would the location of that actually be? Where is it located? Right there, isn't it? Then what can we say then? Huh? R value is a third, isn't it? Yeah. What's the angle? What? So it's going to be 1/3 cos pi plus. Who got that answer there? 1/3 cos pi plus I sine pi. Did you get? Huh? It's minus pi. Is it? It's the same thing though. Same answer when you multiply it back out. Okay? Do you know what I was thinking actually, just halfway through the question? I started thinking, what happens if we just did this? at the very beginning. Just change that into minus 1 and change that into 0. What then? What is it? Would everybody agree it's minus 3 plus 0i? Yeah? And then that's z. What's 1 over z then? 1 over? Yeah, so 1/3 plus 0i, and the 0i doesn't even exist, does it? And then what can I say about the whole question then? It's minus 1/3 plus. Geez, I'm right there already, haven't I? I've already answered part 2 directly. I didn't have to do part 1 first, you get what I'm saying? And now look what happens here. I'm exactly where I was a second ago. I'm at, I know it's minus 1/3. That's length 1/3. That's 180 degrees or pi, isn't it? And I've got that answer so much quicker. If I had done part 2 first and part 1 second, it was a far more efficient way to get the question done. And that is correct. I know the back of the book has it as minus I sign, but it's still correct. Yes?
Would you say it's the right answer if you did like, instead of doing 1 over z, you just do z to the power minus 1, and then you do the multiplication thing?
Yeah, that would work as well. That'd be pretty quick as well. So the other thing is 1 over z. What Jamie just said is an excellent read as well. Is that if you do 1 over z is set to minus 1, okay, and then you're using De Moivre's theorem though, aren't you? The power rule. Yeah, you could definitely do it, but you might not necessarily know of that technique right now.
Okay.
But by the end of the next exercise, you'll definitely use that. Yeah. So what Jamie was saying is what we learned yesterday was if I said if I had this down, if I said z squared, what would your answer be? If I said z squared, what would you do there? Huh? You multiply the 2 by the angle, don't you? So it'd be cos 2 pi, wouldn't it? And I sine 2 pi. And what would you do to the 3? 3 squared, which is 9. And Jamie used the same logic for minus 1. So what you're going to do is you're going to say it's 3 to the power minus 1, which is 1 over 3. And then he says, well, what you do then is you multiply the minus 1 by the angle. So he's going to get cos minus pi plus I sine minus pi. Is that your answer?
Yeah.
Same thing. Perfect. Right. We both used the Moivre's term. Okay. Next one. Show that if z equals this, then 1 over z is the conjugate. What is the conjugate? How do I get the conjugate? Huh? Yeah. there's a lazier way of doing this question. I think we might work with that. You have two choices. Your first choice is you can do 1 over z, which is this. And what you have to do to get rid of it, get rid of the multiply by its conjugate, top and bottom. Okay, anytime you have a complex number on the bottom, you multiply top and bottom by the conjugate to get rid of it from the bottom. Now, on top it's simply cos theta minus I sine theta. We actually did this already today. You should have 4 parts, shouldn't you? 2 parts in the first bracket and 2 parts in the second bracket. We know the middle 2 parts cancel. Why? Difference of 2 squares, conjugate. So we're only concerned with the first part and the last part. So we're going to get cos squared theta. And then the other part is minus I squared sine squared theta. And what did we say about minus I squared? And what did Connor say about cos squared theta plus sine squared theta? 1. So we've actually just got the answer of the conjugate left over. So that's proven. Is that alright? Yes, Ben?
Is like cos squared any angle plus sine squared any angle 1.
Now, this one. Oh, not again. Find Z in the form A plus BI. Alright. Suppose we could do you know, they do sort of want us to use they want us to use the maths from this chapter, don't they? Like, I'd be very tempted just to do this. What's cos pi over 4? What's sine pi over 4? Everyone on board so far? And you know what I'd do? I'd just throw that underneath. And what can I do both sides? Multiply top and bottom by its conjugate, okay? Now, I have a feeling that's not what exactly they had in mind for us, was it? Given that we're in this exercise. So you could do top and bottom by the conjugate there, that'd be no bother. I think we're gonna try the Jamie's method again. Yeah. What? It's root 2 over 2, is it?
Yeah.
Now I have news for you. Root 2 over 2 is also 1 over root 2. Because you can change 2 into root 2, and they cancel, and that leaves you 1 over root 2. Alright, so sorry lads, just burning Mick, the grand. Well, okay guys, what I saw her saying is that if you do want the answer, you multiply top and bottom by the conjugate. Did you get the correct answer last night? I'll tell you what, since you already have it the correct way, will you pursue that way on your own? Alright, and see if you get the same answer. Okay? So that's for Mick, that's Mick's side project. Alright? We however, that should work. There's no reason why that shouldn't work. It looks a bit awkward compared to what we could do though. I think there's an easier way. So some people might do that in the tests. I think I'm thinking a bit like thinking a bit more like Jamie is at the moment. I'm gonna do this. I'm gonna put it underneath. See the way I'm just cross multiplying it underneath. And then what I'm thinking is I'm gonna use the Myers theorem with the powers again. And that's basically that number to the power minus 1, isn't it? So if you're wondering how I got that, 1 over x is x to the minus 1. 1 over anything inside the box is that box to the power minus 1. So essentially what I'm trying to say is this part here is all contained within a box, and it's cos pi over 4 plus I sine pi over 4 to the power minus 1. Okay? And what I'm thinking is I'm going to do what Jamie was thinking, is just multiply the power by the angle, and this time we're going to get a negative angle, so it's going to be cos minus pi over 4 plus I sine minus pi over 4. Close that. Go to my calculator. Make sure she's in radians. Alright guys, so negative angle. Thank you. That's minus root 2 over 2, or 1 over root 2, depending on which way you're looking at it. I like this one. Don't ask me why. And then the other one. Who got that? Yeah. Did anybody get this version of it? Yeah. Mick, did it lead you to the same place?
No.
Oh. Alright, guys. This one here. Interesting stuff. I'm taking two methods for this. You could use identities, which is identities is where a very basic identity would be something like this: a plus bi equals 3 plus 4i, a equals 3, b equals 4. So see the way that's 2 cos theta? What I'm actually seeing is plus 0i. I'm seeing it like that. Okay? And that means I can sort of try and figure out something using real and imaginary parts. Okay? So here's what we'll do. We'll sub in what we have first. I sine theta. Now, do you know what? I'm 2 steps ahead of myself, and I've already seen a problem I can't fix. So, I'll tell you the problem I'm working with at the moment is, alright, there's an easy way and a difficult way of doing this, alright, and what I'm thinking is, what I'm currently thinking is, it's the last question, isn't it? So I think all roots are difficult. So I'm going to have 1 over, it's going to be 1 over cos theta plus I sine theta equals 2 cos theta. Okay? Now, I suppose one possible way would be just a common denominator. We could go for that. Okay? So, if we common denominator this, what does that mean? I'm actually using trig. So, would you believe I'm going to multiply top and bottom by cos theta plus I sine theta? Is that alright? Currently not using the maths we at the start of this chapter. Okay, so I'm going to multiply that out. I also have to do the same to the other side, don't I? I actually have about 4 different ways of doing this in my head right now. And here's what we're going to do. I'm just going to multiply it out. Fortunately enough, I don't know which one's the easiest one. Alright, so that's cos squared theta plus 2i sine theta cos theta. Is that okay? Now what's I squared sine theta? What's I squared sine squared theta? Which is minus sine squared theta. Is that alright? Now, what do we know about that other part? That's just plus 1, isn't it? And then we're going to multiply this out now, aren't we? Have to show that both sides equal each other, is that correct? So I have to show that the left side equals the right side, that there's balance. Is that okay? So that'll be 2 cos squared theta plus I sine theta cos theta. Oh, 2 of them. 2 of them. Yeah? Now, does anything currently match up? What matches up? The 2 of them match up nicely, don't they? Nearly there. Does anybody have a substitute that will make this work absolutely fantastically? I'm going to get rid of that 1. And what am I going to replace that 1 with? Is what? Exactly. What happens to the sine squared thetas? And then what's cos squared theta plus cos squared theta? Yeah. Did anybody go about this in a different way? Everybody. Alright, what was your method? Works out a bit nicer, does it? What?
Much nicer.
Much nicer. Alright, let's go for that. So, just shows you there's tons of different ways. That's a real trigonometric approach, isn't it? It's not really the complex numbers approach. So, we'll try what Phelim said. So, Phelim zoned in on he zoned in on 1 over z. Do you do top and bottom by the conjugate? Okay. Okay. Bet you the bottom's 1 again, isn't it? We've already multiplied that out about 3 times in this class. The answer is going to be 1 on the bottom. And then you have, oh yeah, this is much nicer. Okay. So we already have 1 over z. That's 1 over z right there. And then what we're going to do is we're going to add z to 1 over z. And then we have to prove that it balances. And it does, doesn't it? Yeah, that's much nicer. That's a much better way of doing it. Alright, there you go. 2 different ways of doing it.